So flammables, we've all done this before. A little quiz. What's our lower explosive limit? Anybody know?
What's the lower?
Lower explosive limit. What is the definition of a lower explosive limit versus the upper explosive limit?
The temperature which it self-combustion.
Oh, you guys. All right. I see we need the training. Okay. So we'll talk about properties, how to identify them, how to store them, how to control sources of ignition, open spill, kind of the same thing we talked about before. You know you can put a match out in gasoline, right? Just better make sure that gasoline isn't giving off enough vapor to support combustion, because if it is, you're going to blow yourself up first, right? So, got to consider the behavior of the vapors. Is there going to be enough? That's our lower explosive limit. That's the concentration of which there isn't enough vapor in the air to support combustion. It's too lean, right? And then we get to our upper explosive limit. That's where it's too much. It's too rich. It's too much fuel just to keep it going. In that area in between, that's the flammable zone. That's the area where there's enough concentration of gases, vapors in the air to keep combustion going. So, you know, when we talk about flammables, that's our job. Don't get that concentration in that combustion range. Either have it be too weak or too rich so that you can't, or don't have any in the air to begin with. So what do we know? Well, the larger the surface area, the more vapors are going to be generated. You know, it's amazing. You spill a 5-gallon container, it looks like a tank truck. I mean, it's huge, right? It's a little 5-gallon pail, and you look at the area on the floor. So it doesn't take a big spill to get a big volume of surface area that is exposed, and if it's flammable, the greater the surface area, the more the evaporation, the more likely you're going to have to where that vapor is going to be in that ignitable range. So we talk about it. Fire, what do we need? Source of ignition, some oxygen, and some fuel, right? So we talk about the fire triangle. We talked a little bit before about chemicals, that hey, you can have friction, you can have other things that cause a chemical reaction to start a fire. But what's the key? If you don't have one of the four, you won't have a fire. So you get rid of the oxygen, you get rid of the heat, you get rid of the fuel. One of the things, you're going to have the fire go out. So what are significant material properties? Well, here's some of the things we talk about. This auto ignition temperature, which is it's a temperature where the liquid is going to ignite without an additional ignition source. I can't even think with any of our products what that would be. Boiling point, obviously we know what a boiling point is, the temperature at which something boils. Flash point, that's an important one, so that's temperature related, right? And so when we talk about flammability inside a customer's facility, or what temperature is this stuff going to be at, right? Because the warmer, depending on where this flash point is, as you get closer to that, it's going to be giving off more and more and more vapor. And the flash point is the temperature at which there's enough vapor given off continuously so that it can support combustion. Ignition energy, again, I'm not sure where that one all comes in. That's the energy that you have to put into a vapor to get it to actually start. Well, here's where I mentioned this before, this minimum concentration which will ignite. So if you get below the lower explosive limit, there's not enough fuel. And we have the upper limit where, hey, there's too much, it's too rich. And so we want to try to stay out of this range right here, because this is the range at which there's enough vapor to keep that thing going and keep the fire going. Now, in a lot of cases in our boiler rooms, because what are we talking about? We're talking about our steam line treatments primarily. And realistically, you have DOT and OSHA, again, related to flammability and flash points. Most of our boiler rooms have amazing ventilation, right? You got all the air for combustion that you have to to burn the gas and the fuel. So in most cases, I can't see where with the concentration of products that we have in a space that it would ever get to a point where we'd have to worry about an explosion. But again, same thing. Don't put your steam line treatment right next to the hot water heater. Just use good common sense. So how do we identify flammable and combustible liquids? This is what I was talking about. So DOT and EPA, all related to this flash point, right? So what's that temperature of the liquid where it's going to be giving off enough vapor to support combustion? So EPA says if the product has a level of 140 or less for the flash point, then it's considered flammable. So if it supports combustion at 150 degrees, it's not considered flammable. But this is only for transportation, right? This is to get the stuff there. This is what dictates in our plants. It's what OSHA says, right? And so OSHA says it's a liquid with a flash point of 100 degrees or less, and most of our products are going to fall above this, over 100. Yet there's still guys like Flammable paper that say we have to put our steam line treatment drums in flammable steel proof containers. So a combustible liquid, EPA doesn't regulate or recognize it. OSHA says there's different classifications. So a class 2 is a flash point between 100 and 140. Class 3 is 140 to 200. Combustible liquid, again, that's heated to within 10 degrees should be treated as a flammable liquid. Again, same thing with us. I don't know, some of our boiler rooms can get pretty damn hot in the summertime, right? I mean, hopefully, though, they're not too much more than 100 and 120 degrees, although I know some of them can get pretty hot. But again, it's OSHA that we're worried about. These guys are DOT, and that's more primarily from the placarding on the truck and the bill of lading. Make sure all that paperwork, should they get pulled over, that their documentation reflects what the DOT considers to be a flammable product. Isn't that amazing? The DOT and OSHA and EPA, they don't all work together. It's crazy. DOT says all containers must be labeled. So you got a red label, you'll see the little red diamond on there. And they say it's got to be 120 gallons or greater. And is that total? So if you have 2 drums, are you 3 drums, or is that the container itself, Tommy? Okay. Yep. So as it says, this can be deceptive because when it's in the warehouse, OSHA regulations apply, not DOT. So what about some of the properties? Well, a liquid which is at or above its flash point, we talked about that. It's going to be generating enough vapor to ignite and continue burning. If there's a leak, it should be assumed that the vapors are going to reach an ignition source, and then it runs back along that vapor path to the container. So that's what we're saying. Hey, trying to set up drums next to, hot water heaters. And oh, well, it's right next to the boiler. Right, and the boiler's a big flame. Well, don't put the chemical right in front of the burner, right? So it says the lower the flash point, the more flammable vapors are generated, so that you can, obviously the more vapor, the bigger that vapor cloud's going to be, and that can cause problems. Again, I said in a boiler room, we have such good ventilation typically that I don't see that as a big problem. And as the vapor cloud expands, so it's kind of interesting how that works. It's really concentrated, it expands, and as it expands, it starts to get less and less as far as going from really rich to being in that combustible zone to now it's too lean. There's not enough fuel to support the combustion. So what's the big key? Don't spill, right? If the vapor density here, as I said, it's less than 1, it's going to be up in the air. If it's greater than 1, it's going to be on the ground. Hydrogen's less than 1, so that'll be up at the ceiling. Again, ammonia is going to be up at the ceiling, so if there's a leak and you're in an engine room, an ammonia room, get on the floor and crawl out on your hands and knees. Vapor more, that's going to be along the floor. Does it give us any examples? I can't think of anything that we'd be dealing with where we'd have to be aware of that. And what about storage? Again, here's where we're talking about stored in the area. Some places say this specifically designed for flammable liquids. I think there's a picture in here. Fire doors are what Hydrite uses. If there's a fire, they have these overhead doors that immediately close and isolate the fuel, isolate the oxidizers. There's a picture of one at Hydrite that they close in the case of a fire. Isn't that nice? If it's a fire, they're calling them and not me. That's awesome. It says it's don't store flammables within 3 feet of a building's support beams. Top of the drums and storage must be kept at least 18 inch below a fire sprinkler. Where's that going to be important? Hydrite, right? You got freaking pallets up to the ceiling with stuff. That really probably isn't going to be enough for us. Keep an eye on this one, the 3 feet. And then adequate aisle space, if possible. But again, that really doesn't pertain to us all that often. How about controlling sources of ignition? Don't have it near open flames, hot work, tools and equipment, hand-operated tools. Talk about static discharge. When transferring, again, if we're going from steel to steel, you can probably run into problems. I don't know of anybody in our business that does these grounding straps when they're transferring chemicals. For static electricity, there's an example of it, but that's kind of more from a metal container to another metal container.
I've seen that at laws.
Okay. Here's a picture of one of those containers. This is what they have at Flammable. So all the drums of steam line treatment they put inside there until they're ready to use them. But I'm just like, man, what other kind of chemicals do you have in this plant? This is probably the least of your concerns are these 2 drums of steam line treatment. Yep. Yep. Spontaneous combustion, again, in general, I don't care what it is we're dealing with. If you clean up something with a rag, rinse it out. Rinse that rag out. Make sure there's no residue in the rag before you dispose of it. Don't just rinse out the rags and toss them into a garbage. You're asking for trouble. There may not be any problems at all, but let's not take that chance. And if it is flammable, you guys have seen them. Our customers have them. Rags get solvents and other things on them. They have those little red fire, little almost like small little garbage cans that they put stuff in there, and when those are full, they have somebody come and specifically haul away the flammable stuff. Health hazards, what do we have? They're all organic carbon compounds. They're designed to be solvents, same way. You get that stuff on your skin, it's going to react with your skin. Depending on what the solvents, again, says some people may be seriously affected. Some of them are sensitizers. Our steam line treatments, they're not sensitizers. None of the ingredients that we have in there are sensitizers, so you don't have to worry about that. Inhalation, obviously, can be pretty simple, just taking your breath away. None of us should ever have to worry about the long-term effects because we're not working around them 8 hours a day, breathing the stuff in day after day after day after day. So long-term effects, even you guys that are delivering them, they're not doing enough of that stuff. But in general, I mean, what I always say, just try to make sure there's just adequate ventilation. Engineering controls are the best way to prevent any problems. What are some of the acute effects? Well, if they're, short-term exposure, you might get a little dizzy, you might get a little drowsy. I hope you don't become unconscious. If you have exposure, this is more talking about solvents, right? They're not talking our steam line treatments. These are more talking about solvents that are more what we're going to see, industrial solvents and cleaners in our facilities. I can't remember, what is the name of the stuff that you put on wall? Kills or something like that. It gives off these really toxic fumes. My buddies used to be home remodelers. They're like, yeah, man, we get so stoned off of this Kills. I'm like, what are you guys doing? Open the windows, you dorks. I'm like, yeah, and then you looked at them, and you're like, no wonder. So, What are some of the chronic effects? Again, we really shouldn't have to worry about it because we're not around it, but obviously you get exposed to solvents and some of those things. There's definitely some really serious side effects to it. If you notice me with insomnia or mood swings, maybe that's the reason. Skin contact, obviously that's the most common thing, but you're not going to get a burn. It's going to be more like a rash, more kind of dermatitis, going to make your skin real dry, etc. And that's the result of the ability to dissolve the fats and oils. It's going to make it more vulnerable to infection. Again, what's the best thing to do? Just wear your PPE. We have all the stuff you guys need to not have to worry about getting stuff on your body, your clothes, your person. Organic liquids in the eyes. It's going to cause some pain, but it's not anywhere near as potentially damaging. Although, again, you get anything in your eyes, rinse them for 15 minutes. And if it's me, I'm going to seek medical attention. I don't care what it is. I only got one set of eyes. So, but again, same thing. Pretty much everything. If you get stuff on you, if you get it, whether it's on you or in your eyes, 15 minutes, and then go seek medical attention. Spill response. Eliminate all open flames, don't operate any switches, leave the area. Again, talk about ventilation is the key. Turn on those electric fans. Oh wait, no, don't turn on the electric fans. Again, we're with the type of products that we're dealing with. This is specifically the steam line treatments. They don't act like solvents, right? I mean, the only reason they're flammable is more from a DOT perspective than it is from us being in the field, right? These things aren't in the field, giving off tons of vapors. I mean, the concentration is low enough and that sort of thing. So we're talking more here as this relates more towards solvent type products. But again, you still have to be clear. About using a combustible gas detector, we don't have one of those. But that is definitely going to be more anything about going into a customer's facility or entering an area. We're going to rely on a customer. That's not going to be our area of expertise. Although it does say, just from your own expert knowledge, that if they are using some kind of gas detector, whatever it is they're detecting, says don't go in unless till the concentration is 10% below that lower explosive limit at a minimum. When's it safe to enter? When the concentration in the air is measured to determine that you don't need respiratory protection, because guess what? The only guys that are fit tested for respirators are those two yahoos back there, and none of us are permitted to go in any area where you're going to need a respirator. And then again, if you spill, use these booms or absorbent socks. Check out your spill kit, standard operating procedures. And just remember, if it's a flammable stuff, you can't just throw it in any garbage. It's got to be thrown in a specific flammably approved container. Turn the container so that the leaking spot is above the liquid, right? How's that? You got the leak on the bottom, you turn the drum on its side, put the gun in the Gorilla Tape over the hole, use floor dry. And again, common sense. I talk about, hey, that a tote leak and it was in the containment. Well, what do? Pump the stuff from the containment back into the tote, assuming the tote's not still leaking, right? Don't just leave it in the containment. And then it's got to be removed properly. Again, there's that little diamond, but again, that's more for DOT than it is for us in the plant. Questions? So we went through a lot today, right? The big thing is there's specific chemicals you got to know how to work safely around. Acids and bases, biocides, oxidizers, and flammables. Read safety data sheets, read labels. If there's questions, call. We'll get answers. Adequate ventilation is the best way to make sure you don't have problems in your facilities. And what's the next best thing, or the first best thing? Don't get the stuff on you. Wear your PPE. Keep it clean. Make sure it's in good condition. If it needs to be replaced, get a hold of Julie. She will immediately get you the proper stuff. And work safe. Thanks.